Hello again. This lesson today is about scientific notation and the rules of scientific notation. Here is a list of the various rules of scientific notation and what scientific notation is. So scientific notation is just a compact way of writing very large or very small numbers. There's always a factor of 10 involved, which means we're multiplying something by 10. Numbers that are greater than 1 have a positive exponent, and numbers that are less than 1 have a negative exponent. You only record sig figs in your answer, and there's only one number before the decimal. So these are all super important things to pay attention to when writing in scientific notation. You do have a spot in your notes to write down these rules, so take a moment and write these down so you have them for yourself. Here's some practice problems that we're going to go over. So scientific notation is written like this: 1.92 times 10 to the third. What this means is we're doing 1.92 and multiplying it by 10 to the third, and 10 to the third is like 1,000. Has 3 zeros, I think. Let me double check. It might be 100. It's 1,000. Cool. So that's what that means. So instead of writing a giant number, we're simplifying it. I'm going to show you a way to convert things between scientific notation and general notation. Alrighty, I have some problems behind me that are going to help us practice how to convert between scientific notation and general notation. So this first number is 1.92 times 10 to the third. In the rules that I gave you at the beginning, I told you that a positive exponent means the number is large. So if we ever have a positive exponent, we're going to move our decimal to the right. So we're going to make it a bigger number because it's a positive number. So we're going to take our decimal and move it 3 times to the right. When we move it 3 times to the right, we get 192, and then we have one hump left, 0. So this number, 1.92 times 10 to the third, is the same as the number 1,920. Let's do the same for this next one. 1.03 times 10 to the negative 2. Now, when we have a negative exponent, it means it's a small number. If we have a negative exponent, we're going to move our decimal to the left, and we're going to move it to the left 2 times and fill in zeros. So our answer is 0.0103. Quick review question. How many sig figs are in that answer? Hopefully you said 3 sig figs. So that's how you go from scientific notation to general notation. Let's go the opposite direction. So I'm looking at the number 1001. Anytime we're writing a number in general notation, we're going to put a decimal place, one number behind the first whole number. Okay? And what we have to do is move the decimal 1, 2, 3 to get it to where it needs to go. So this number is going to be 1.001 times 10, and this is a number bigger than 0, so it's going to be a positive exponent of 3. We're going to do the same for the next one. We put our decimal 1 spot after the whole number, and it takes us 1 time to get back to the original spot. So in scientific notation, this number would be 1.3592 times 10 to the negative 1, because it's a number smaller than 1. Per usual, I feel as if I didn't explain that super well, so I am going to provide you with a supplemental video if you're still confused. Something I'm going to show you how to do next is solve with scientific notation. So I want to show you how. All Alrighty, so I'm going to show you how to type these numbers onto your calculator so that you can succeed when solving with scientific notation. So you're going to type the number in the same way. So let's say I'm doing 4.1357 times 10 to the negative 15. I'm still going to type 4.1357, like so. However, instead of just typing times 10 to the negative 15th, you're going to use this special key right here that says EE. So you're going to use the second button and then the EE button. So it pops up with an E. That E means times 10. So right now in our calculator we have 4.1357 times 10 to the negative 15. If you use the E function, you can then type your multiplication. So times 5.4 EE, that's 2, 10 to the 2. Okay, so again, when typing my second number, sorry, let me get rid of the glare, I have times 5.4 E2, because that E means times 10 to the second. When I click my enter key, I then get my answer of, the glare, 2.233 times 10 to the negative 12. I'm going to show you another way to type in this exact problem and make sure we get the same thing. So let me clear it out. So another way to type this in is by using parentheses. So you need to put your whole number in parentheses. So we're going to put the whole first number in parentheses. So we're going to type parentheses 4.1357 times 10. Remember this little button here, the caret is the to the button, 15, negative 15, end parentheses. So notice this whole number is in parentheses. If we keep it in parentheses, it will solve the problem correctly. So then we're going to times it by parentheses 5.4 times 10 to the second end parentheses. Notice it gives us the same number that we had before. Let's solve another problem in this way. Let me make myself small again. So let's do 4.7192 times 10 to the second divided by 3.862 times 10 to the negative 4. Again, we are going to type in as follows. And if you haven't already, try that on your own and make sure you get the answer I'm about to get. So we are going to type in, I can try to do it upside down. Actually, I'm going to switch sides of the computer. One moment. All right, I'm just upside down. 4.7192 EE 10 to the second divided by 3.862 EE negative 4. And you should get this answer. Just for the final portion of this video, I do want to go over sig figs with scientific notation. Sig figs are still going to apply. So in this question here, we had 5 sig figs here in this first answer. We do not include the times 10 to the second in this counting the sig figs. So this 4.7192 has 1, 2, 3, 4, 5 sig figs, whereas this 5.4 times 10 to the second has 2. Okay, it doesn't have 1, 2, 3, 4, 5. We don't count all the numbers. We only count the number before the times 10. Per usual, if you have any questions, please reach out. Thank you.